We want to mount this full spectrum P-motive battery in a car that we've been working on. It's a little bit different application, not your typical door car, and it has kind of a tight spot to mount the battery. When we got the car, we ended up redoing the whole car, and what was on it was this. And it went over a regular battery. It wasn't this battery, but it's almost like, I don't know if they ran out of time or they ran out of talent or what happened, but this is what was on it. And it's not great. As you can see, it's not really constraining the battery the best. It's kind of holds it down-ish, I guess you could say, but we are going to make it better. We're going to try something different. We're not going to reinvent the wheel, but we do want to get this securely mounted. And this is a lightweight battery. This is an expensive lightweight battery. We don't want, some 5-pound hunk holding down a 15-pound battery. It's just not required. It's just not necessary. It's too much. So nobody wants to spend all this money on a nice, good performing battery and then throw a bunch of extra weight in it when you've spent the money to save some weight. So we'll try and make it as slim as possible and have some extra features on it that we think will make people's lives easier. And if it goes well, we'll go ahead and sell it. Here's the setup we were talking about, and this is after we wired it in. You can see that this is sitting behind the seat and above the rear end. So it's got a cantilever shock system. It's right in front of the shocks. So we have this much room to work with. It fits, but we have it in here wired up. Of course, nothing's really tied up or tidy. You can see the battery cables going down to the starter, hooked up with rad locks. Check out that video we've got on the details of the rad locks. Those are two gauge wires here, cables. And then this is some grounds for the ECU, power for the ECU. And then we have a couple other little things for a charger lug that's hooked up to the back. So a charging port is right there. And one thing that we've got going on is a contactor for the disconnect, and it's just kind of floating right there. One of the requirements I want is to be able to have some method to be able to mount the contactor on the side of the battery mount in order to give it a place to land. So we have space for that over on the side, even if it's sticking out. And then this will feed up to the relay panel. Thing I'd like to have on the battery mount is to have some sort of details on there to fasten down cabling. I'm not really sure what that looks like at the moment, but I'd like to add some features to it to hold down cabling once things are in place. All right, so now that we've got the battery in the location where we want it, we have it rough wired in. It's, we've got the cables going where we want them. It's time to define exactly how we want this to be. A couple of requirements. We want it to be lightweight. We want it to be minimalist. One thing that's been on my mind is that is there really a need to have like a full plate on the bottom? If it's elevated slightly and it's captured on the corners, is that enough? I'm thinking so. I'm going to explore that option, see what I can come up with. It's got to not be this. We talked about this early on. We talked about restraining something. We talk about like 6 degrees of freedom, meaning we want something to be fixed so we don't move back and forth, left or right, up or down, or twist in any form or fashion in 3 axes. So you got 6 ways you need to make sure this is pinned down. So most do a very good job at that. Some are a little bit heavier than I would like. Again, this is a lightweight battery, an expensive battery. We don't want to have it any heavier than possible, so keep it minimalist. The other thing we talked about is having some way to manage the cables. Whether that be have a place to zip tie them, hold them off, whatever. Just something a little better than what we normally see on a battery hold down. And I think we can come up with something that will be a little better than what's out there right now on the market. We do have the CAD for this case. We'll start by putting that in and just start building some pieces and see if we can come up with something decent. Okay, we were lucky enough to get the CAD model here for the 2K case. So that definitely helps us out in our design work so we have an accurate model to work with. So one thing I want to point out about this case is that the perimeter sticks up more than the center. So if there was a full plate on the bottom, really only the perimeter would be touching. So I thought, well, if we're going to split the base and have 2 different portions, then we can just seat it up here, and you can notice it just follows that, call it the high spot around the perimeter of the case. So we did give it some thickness here. You can see how the case sits down inside of a pocket on the corner, kind of capturing the corner, keeping it from moving left or right, forward or back. And we gave it some depth because on the bottom it's going to have to sit flush, so there's a countersink screw there. Of course, if you had like a regular bolt there, it would be sitting up on the bolt. So we gave it some thickness for two reasons: for both the countersink and to capture the corners. And then we'll have 4 places to bolt it down. Of course, it'll look just like a mirrored image on the other side right there. Okay, so yeah, once that gets bolted down and when it's assembled, then you have 4 points to mount from. One thing I was going to mention was that we do have a pretty tight corner here, meaning that the case does have a radius on it, but that's pretty tight. So when you're machining something, your tool is obviously round, so you have to use a really small diameter to get in there and pocket that out. Talked to John about that. He works magic, so he'll be able to get that machined out. And then, of course, to be able to mount it, we went ahead and put a vertical portion on it, and that'll be on both sides. So this spacing here is going to be the same spacing that we put on the top. We did pocket this out some. And then, of course, the bolt down on top. So we have the holes here on the side and on the top, and that's going to be what allows us to fasten some cable management down. So we kept it very simple. Thought about a couple things, adding them in, but because this is a very generic battery, meaning that you can use it in any application. It's not just for a certain type of car that will always be wired the same way. This allowed us to keep it simple and give a few options for things to bolt down, and then we'll go ahead and design some things for cable management that can fasten to those. My thought has always been to make it as simple as possible in the design. Work is not done until it's as simple as possible, but yet still works. So I didn't want to constrain the use of the mount to just certain applications, but keep it more generic and flexible for the thousands of different applications that this exact battery will go into. Overall, I would say that this should work out pretty well. I think it's time to go ahead and 3D print it and assemble it onto the battery and see how it fits. All right, we've got these parts are 3D printed. They've got some carbon infused in them, so somewhat strong, but of course we will machine these out of aluminum when we have our design sorted out completely. So 5-piece design. We've got the 2 base pieces that should capture the bottom verticals and the top tie down. So let's go ahead and put this together. Seems to fit pretty good. This print seems to be pretty accurate and fits pretty good. We have pockets in here. And like we said, we wanted to be able to bolt this to the side of it. So the spacing on these is the same as these bolt holes. And most of them on the market have that same spacing. So able to screw that in directly on the side. And then we're on the top. There's some common hold downs out there that we'll probably use. And let me see, I can probably grab one of those and put that on. Yeah, something like these. You can find these out there just about anywhere. Just a cable tie mount, and we'll just tighten that down with a 1024, and that'll allow us to zip tie some things up. Once the hold down assembly is put together, assembled onto the battery, then we can go ahead and pin it down. So we have a template here. We can simply just mark each hole with a template, put it to the location where you want it, drill the holes, and then move the battery into place. Or just put the whole assembly into place. Because these fasteners are outside the battery, it's not, underneath the battery itself, we can just go ahead, use a transfer punch, drop it in, give it a couple taps, remove the battery from the location, drill the holes, and then bolt it down. I think it's time to go ahead and machine some of these parts, so let's get to it. All right, parts are machined, turned out great. Got two of the base piece, then two of the vertical riser, and then the top clamp down. So one thing I wanted, as I noted before, is I wanted to be around a pound or less. So I guess it's time to see how well we did. I thought it'd be pretty close. You can get an estimate from your CAD, but you never really know until it's off the machine. So there. All right, looks like we are a couple ounces heavy here. Plus there'll be a few fasteners, so may have to put this on a little bit of a diet for the final revision, the final version. Possibly pocket out these holes completely, do a few things. I have a few ideas where we can make it a little bit lighter, but not too bad. Really close to target. So, and we will have a few fasteners as well, so that will increase that. But not too bad. We're close and good enough to proceed and see how well it works and put it into practice. All right, this seemed to have gone together pretty good. This is the point where we find out how rigid it's going to be with the 3D print. You know, it was pretty flexible, so yeah, at least the way I printed it, you know, this will tell us how rigid it's going to be, how well it's going to hold the battery down. Everything seems to fit in. The corner's good. That's kind of a tight radius, so was worried about that, but it seems to have come out really well. And that's part of the reason I do like using the transfer punch when it's all assembled, because there could be some slight variances in exactly how this gets bolted together, but it really isn't that much. So the template works just fine as well. But yeah, it's feeling pretty good. Battery doesn't seem to want to move as far as inside of that. It doesn't want to flex out. Yeah, especially once it's bolted down, it's definitely not going to go anywhere. I'm sure you can flex this out if you really try, but once it's bolted down, that essentially gives you a fixed platform, keeps it from moving left and right, up and down, wanting to twist or anything. So I think we're good as far as rigidity on the hold down. So I think, you know, at this point, you know, we can install it. We can, this will all be anodized black, so we'll send that out for anodizing, and that should look sharp. Maybe engrave a Maven logo on the top or whatnot. All right, we can go ahead and put this thing in the car and see how it does. You can see it's bolted down at the base there, 4/4 inch bolts, and then we've got the contactor. We've got that wired up, and it's mounted directly to the vertical post on the mount. So just simply put the two 1024 screws in and you're ready to go. Coming up to the top here, these two holes, which is actually the same bolt spacing as the other one, so you can put the contactor on top if you want, but we just screwed down two of the simple cable tie downs and put zip ties around them. Holds it in place. Gives you a nice place to feed through. Over here, we have, as you can see, these cables are still floating out there. I'm not super happy with that, but I do have these two holes here. So I made something. I'll show you how I did that here in a second. But notice how we have these cables here for round tubes that we made. I like this because oftentimes if you wrap a zip tie all the way around, you kind of have these gaps down in the corners. This actually is sized to the cable size, and then a zip tie goes actually underneath the cable and stays around the tube, keeps the zip tie in a round fashion instead of going all the way over the cables, and it captures this right here. So this is something we've been using a lot, is these cable tie downs for capturing. So these little widgets we've been using a lot for round tube. Makes life easy just with zip ties to put it on, but yet Works a little better in my opinion. I made something similar for the battery mount. Now notice it stands off a ways. So took a couple measurements and allowed this to come off further. So we'll show you that. We'll use this to tie off those 2-gauge cables. And notice, this is relatively long, but that's how long it needed to be to space out to where that frame rail is. And notice it has a through hole. So you just slide that screw through. You can screw it into the battery hold down, and then the cables go in. And in this case, this is what we like about these, is that the zip tie goes through there. We got actually 2 of them on there in this case. So you slide these through. Again, this is 3D printed. Probably not something you're going to machine like a feature like that inside of here, at least not in this fashion. So yeah, there you go. We'll have a couple of these on there, and the battery cables will go through. We'll zip tie them down, and that should give us a tidy method to control those cables. Here's the model of that hold down for the 2-gauge cables. You can see it's got the through hole to screw it down, and it has the 2 sections here to put the zip ties around. Section that out, you can see that the zip tie just feeds all the way underneath. And that's all there is to it. Here's a short version of that same thing that we used to stand off. Just wanted to show that. That would keep the cables nice and tight to the battery mount. Here's another option that would clamp them together but yet separate. Just a different way of accomplishing the same task, but they are going to be separate because you have the screw going through the center, so they won't be right next to each other. Here is a brake line mount to the 2. This is off topic, but we were showing the cables mounted to the side. These are both the same type of thing. You can see how the zip tie will go through and underneath the cables, cross over and wrap around the tube. And it's the same principle with this single brake line. You could do too. Anyways, just some ways to help manage, I guess, cables and tubes, hoses, that sort of thing, that anybody can really set up something like this to, print on their 3D printer. That's what we did, and it works out great. Just use the right materials and whatnot to hold up to the application. Just wanted to show a few different things for cable management or hoses or brake lines. So we've just screwed those parts into the side, and hopefully these will help take these unruly cables and get them straightened out a little bit. So we'll just push these into place. Should be pretty snug if everything is correct here. Yeah, it's almost like staying there without the zip ties just because of how snug it is, but there we go. And I'm thinking, like, maybe I'll just put these on the website so that people can download these. And I mean, anybody could just, design something similar depending on what size their cables are, just a million different options. So, but this would give people something to start with as far as a CAD model if they wanted to make something. Of course, everybody's application is going to be a little different, but should work out pretty good. That just makes everything look a little more kosher. Trim those zip ties, and that should be good. You can see it from there. Just kind of helps make everything a little more smooth. So yeah, you can see you can match up the radius of your starter cable and your ground to make those matched. Just by slipping them through that little retainer, your cable retainer. So let's say if these were removed and you didn't have that, you could also do something. Let's say if it just kind of looked like this, you could use these 2 holes here, and you could, just have like a simple plate. It could be out of carbon fiber or aluminum. Yeah, let's say if you wanted to have like a mega fuse mounted there, you could just bolt it to the plate, run your cable through that fuse, and it gives you some options just to have a simple plate bolted there. So just those 2 screw holes, which is very simple, nothing overly complicated, right? But it really does give you a lot of different options for your cable management around your battery. So I think at this point, it's probably time to get these parts anodized and finish this project up. Okay, wanted to give a quick update. This is actually after the fact, but I want to insert this. We have a slight change in the design like we talked about, making the pockets that were in the risers into through holes to try and take a little bit of the mass out of it. We were at 1 pound, 2.9 ounces with these pieces before, and now we are at 1 pound, 1.2 ounces. So took a bit of it out, close to 2 ounces, and then this will be the fasteners. So let's just call the weight 1 pound, 2 ounces. So we are gonna go ahead and stick with this, and it got us pretty close to our target. We are back from the anodizing process and gave it a little Maven logo. I gotta say, it actually turned out pretty good. I mean, we do quite a bit of work on the aluminum before it heads out for anodizing, so it looks, has a shiny look to it and whatnot. But definitely happy with how it looks. A few little tweaks for the next production run, but I think that we're in good shape. I think people will like it. I think we'll provide a couple of these with each one, so people have something to tie down. And again, people can make whatever they want. You know, so many 3D printers out there now. It seems like everybody's got one. Simply just make it to bolt down to the 1024 hole, and again, like we were talking, you could literally just screw like a plate here if you need to add a bunch of accessories or pin some things down. Otherwise, it just gives you a lot of flexibility. Yeah, again, we didn't cure cancer, we didn't really reinvent the wheel, but we added a few things that I think will help people out, make life a little easier when they're wiring it up. Again, we have these core 20 holes that are outside, so if you do want to mount the whole battery in, you can literally just unbolt these holes and take the whole entire thing out. Or in a standard fashion, you can just take these out. Sometimes the bolts or the fasteners, main fasteners, are underneath the battery, but in this case they're not, so you can take the whole thing. And in the case, in the application we've got here, it definitely is a bit tight, and it's actually probably easier to take these bottom bolts out and slide it out. So just depending on what your application is, you have both options either way. So yeah, I think that I'm pretty happy with how it looks, how it functions, and we'll go ahead and slap this thing back into the car and finish it up. All back together with the anodized battery hold down. The plate, the hold down plate here is black powder coated. Shout out to Stevie at TSR. Got that knocked out for us. Here you can see how we trim the terminal caps, the red and black rubber caps, to work with the different rad locks and cables we have bolted to it. Pretty easy to trim. I used just a round punch to open up some of them, and then just did some trimming with a utility knife. Works out great. Contactor mounted to the side. Have a lot more confidence in the hold down than the previous one. Hopefully we went from like a 1 out of 5 to at least like a 4 or 4.5 out of 5. Drop a comment, let us know what you think about it. If you like it, great. If you don't, even better, tell us what we should have done different. FT600 on board. Good quality power source to feed the electrical needs. And again, thanks for watching.